Hello, ladies and gentlemen, and welcome back. Root Beer here, wishing you well. And hopefully you're as excited as I am to finish off our 2011 Grade 8 Gauss with question number 25. Daryl first writes the perfect squares as a sequence. 1, 4, 9, okay, sure. 100, and it looks like he keeps going. After the number 1, he then alternates by making 2 terms negative followed by 2 terms positive. So 1, negative 4, negative 9, then 16, 25, negative, negative, positive, positive, negative, negative. Okay, I understand this now. What is the sum of the first 2011 terms in the new sequence? Interesting. Okay. So for something like this, 2011 is really big. We're not going to be able to grab our calculator and just get an answer. So what we want to do is maybe look at a smaller case, maybe try and notice some patterns. And there's definitely some patterns to be found. I mean, there's a pattern in the way the minus signs are being put in. There's a pattern in what numbers we're actually talking about. So for example, the kth term in the sequence is k squared, but it's plus or minus, and I don't know whether or not it's plus or minus. It entirely depends. But the kth term definitely is a square. Now, I noticed that our pattern of plus, because it starts with a 1, minus, minus, plus, it repeats every 4. Okay, plus, minus, minus, plus, minus, minus. So let's maybe look at groups of 4 and just add up their sum. So what happens here? Well, 1 minus 4 is negative 3. Negative 9 plus 16 would be 7. And that adds up to 4. Okay. Then next we'd have 25 minus 36 minus 49 plus 64. And the difference of those two is negative 11, and the difference in those two is positive 15, which adds up to 4 again. So noticing that the thing repeats every 4 is kind of shown me a little bit of a pattern. Now, the reason this works is because differences of consecutive perfect squares are just the odd numbers increasing in order. And we just skip over the difference between these two. Difference between 4 and 9 would be 5. And so we get 1, negative 3, skip an odd number, get 7, and that gives me a difference of 4. So it looks like groups of 4 add up to 4. Okay. So now that I know that, if we were to imagine the bigger version of this sequence, it just keeps going. Where's the latest group of 4 going to end? So 2011, if I divide that by 4, obviously it's not divisible by 4, but if I grab my calculator and divide by 4, I get 502.75. So 502 times 4, which is 2008, is sort of going to be the last one. So we get 2008 squared. I'm not going to write it out. It would be a positive 1. Then the one before it would be negative. The one before that would be negative. And the one before that would be positive. And the same sort of rule applies. Groups of 4 add up to 4. So we get a 4, a 4, a 4, and then this last one is 4. Now, how many groups of 4 is that? Well, I just said it. It's 502. So far, our sum is 5024. Well, 502 times 4, which is 2008. But then, what do? We do 2009 squared, and then it'll be minus 2010 squared. And what's the difference there? Well, if you want to, you can grab your calculator, or you could say the difference should be 2009 plus 2010, but make it negative. But we can grab our calculator if we're not confident in that. We can get, okay, this is minus 4019. And then it'll be a minus, because it goes plus, minus, minus, so minus 2011 squared. So minus, and then what's 2011 squared? 4,044,121. Now, before I finish this up, I just need to add this, this, and this. Another thing we could have done is said, well, we're really close. If we just added on a 2012, we'd have another group of 4. So we'd actually have 503 fours and subtract 2012 squared. That would also work because we've added an extra little bit that we're not asked for. And doing both of those would be fine. I don't know which one's necessarily faster or easier to see. Okay. But for either one, we should get an answer of negative 4,046,132. And if we even do it the other way that I suggest, we'll get the same thing. Okay. So 4,046,132. Do I see that as an answer anywhere? Yeah, there it is. It's E, and that's what we're going to bubble in. And that finishes off the paper quite nicely. It's an interesting little pattern that we notice here. And all you do to sort of find those sorts of things is say, wow, 2011 is really big. There must be some trick. There must be some pattern. Let's look at small cases. Okay? First few, the first 10 or something like that. You can even just start adding them on one at a time until you notice that, oh, hey, it's 4, and then a few terms later, oh, it's 8, oh, it's 12, and that's all you have to do. Okay, just realize this is too big a task, so there's got to be some trick. Let's look at smaller cases. Let's not try and do the first 2011 terms. Let's try and do the first 11 terms, that sort of a thing, and see what we can see there. So E is going to be our answer, and that's a nice way to close off the contest. If you're looking for more 2011 level papers, I did do the grade 7 Gauss, and up next will be the grade 9 level Pascal paper. If you're looking for more grade 8 Gauss contests, I've got a wide range of selection. Feel free to browse the channel. Thank you guys so much for watching, and I will see you for more math in the future. Take care.